Let's take a look at probabilities for outcomes that are not equally likely. So it's important to realize that in many situations, the outcomes are not equally likely. So a coin or die may be unfair or biased. Two math professors in Europe had their statistics students test the Belgian €1 coin, and they discovered that after 250 trials, a head was obtained 56% of the time, and a tail was obtained 44% of the time. The data seem to show that the coin is not a fair coin. More repetitions would be helpful to draw a more accurate conclusion about this bias. Some dice may be biased as well. Look at the dice in a game you have at home. The spots on each face are usually small holes that are carved out and then painted to make the spots visible. Your dice may or may not be biased. It's possible that the outcomes may be affected by the slight weight differences due to the different number of holes in the faces. Gambling casinos make a lot of money depending on the outcomes of rolling dice. So casino dice are made differently to eliminate the bias. Casino dice have flat faces. The holes are completely filled with paint, having the same density as the material that the dice are made out of, so that each face is equally likely to occur. Later, we'll learn techniques to use to work with probabilities for events that are not equally likely. Example 5. The probability that a particular knee surgery is successful is 0.85. Find the probability that 2 knee surgeries are successful. Catch my mistake. So I'm saying P, the probability of 2 knee surgeries are successful are 1/4. In this example, the sample space is successful, 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 failure, failure, success, and failure, failure. But the probabilities of the events are not the same. So to answer the question, what's the probability of 2 successes? It's not 1 out of 4. To calculate probabilities, we need to discuss additional probability rules. So now we're going to look at or and events. An outcome is in the event A or B if the outcome is in A or is in B or is in both A and B. So an example, let A equal 1, 2, 3, 4, 5 and B is 4, 5, 6, 7, 8. If we are looking for A or B, it would be any of those numbers. And just notice that 4 and 5 are not listed twice. You don't need to do that. So if you have an outcome and event that is A and B, the outcome is in both A and B at the same time. It's where they intersect, okay? So if we're looking at A, 1, 2, 3, 4, 5, and B is 4, 5, 6, 7, 8, then you know that A and B is where they cross over, where they intersect, which is at 4 and 5. Next, we've got the complement of event A prime. The complement of event A is denoted A with the apostrophe, and we read it A prime. A prime consists of all outcomes that are not in A. So notice that when you add the probability of A and the probability of A prime, you get an answer equal to 1. If the area of the rectangle is considered the probability to get outcomes in the sample space, then the remaining blue area is the probability to get outcomes in A prime, and the red region of the circle is the probability to get outcomes in A. The complement of A is A prime. So let's take a look at this example 8. So if the sample space is 1, 2, 3, 4, 5, 6, and A is 1, 2, 3, 4, then A prime is anything that's not A. So that would be 5 and 6. Okay, the probability of A is there's 4 values in A divided by the total number in the sample space of 6. So 4, 6. And then the probability of A prime is 2 out of 6, 2/6. And we have to make sure then that when we add those together, we get 1. The conditional probability of A given B is written this way, and we read it as the probability of A given B. That's the probability that event A will occur given that event B has already occurred. So a conditional reduces the sample space, and we calculate the probability of A from the reduced sample space of B. So example 9, so suppose we toss one fair six-sided die, and the sample space is 1, 2, 3, 4, 5, 6. If A is 2 or 3, and B is 2, 4, and 6, to calculate the probability of A given B, we count the number of outcomes, 2 or 3, in the reduced sample space of B equals 2, 4, and 6. Then we divide that by the number of outcomes in B. So the probability of A given B is 1 over 3. If we are in the green circle, how many outcomes of A are there? One of the outcomes we see in the green circle is from A, and that's how we get 1/3. After we learn more rules, we'll develop a formula to calculate this.